Okay, good morning everyone. In today's class, we'll discuss symmetrical Z and Y matrices for reciprocal network. In the previous class, we had started with the second module, that is your microwave network theory, and we have seen what is the microwave network. So that is nothing but your interconnection of all the microwave devices components, that is resonators, attenuators, phase shifters, all those things forms a microwave network. And we have seen what are the different parameters that are used to define the any two port network. So we have seen Z parameters, Y parameters, H parameters, and also ABCD parameters. How they gives a relationship between the voltage and the current, correct? And these four types of parameters can be used only for the low frequency networks, and these are not useful for the high frequency networks. This also we are discussed in the previous class, and there are some limitations which are there to use these parameters for high frequency network. That is, there is unavailability of the voltage and the current meters. So you can't measure the voltage and the current using the regular meters. There is no equipments available to measure the current and the voltage for a high frequency network. And usually when we are considering these parameters, that is Z, Y, H, and ABCD parameters, either we go for short circuit or the open circuit method. But in case of high frequency network, that is your microwave networks, it is not possible to do the short circuit method, especially the open circuit method, because it will lead to errors. Okay, that is one thing. So what is the one more thing we have discussed in the previous class is measuring current and voltage by making use of short circuit or the open circuit. What happens is active devices. So you have to you have to place the active devices in the circuits, that leads to instability of the circuit. So these are the limitations of the parameters that are available for the two port networks, which cannot be used for your microwave network. So we had come up with a special parameters which are described for microwave networks, that are called as S parameters, or it is also called as scattering parameters. So these S parameters are scattering parameters that deals with the amplitude of the incident wave and the amplitude of the reflected wave. So these all we have seen in while discussing the transmission coefficient, reflection coefficient, and how we used to take the incident wave and the reflected wave. The same thing we are considering here to define the S parameters are scattering parameters. Till here we are discussed in the previous class. Okay, so now in today's class we'll go with another topic, that is symmetrical Z and Y matrices for reciprocal network. So here what we have to do is, what this mean is, in a reciprocal network, that is reciprocal network is nothing but the voltage and current are independent of the direction of the current. Okay, so in a reciprocal network, the impedance, that is nothing but your Z, and the admittance, that is Y, matrices are symmetrical. That is, if that we'll see what we have to prove here. Okay, so this proof. Now we are considering a multi-port network here. So for multi-port network, let us take Vn plus is amplitude of the incident wave, or you can write it as incident wave amplitude. Vn minus, it is reflected wave amplitude. So here we are considering multi-port network in which Vn plus represents incident wave amplitude, Vn minus represents reflected wave amplitude. Okay. So the overall voltage you can give it as V is equal to Vn plus 1, Vn plus and Vn minus. Okay, and this will be equal to 0 for all ports. That is for all n ports. For all n ports, we are taking V is equal to Vn plus Vn minus. That is nothing but the amplitude of incident wave plus reflected wave will give you the overall voltage for all ports, that is n is equal to 1, 2, 3 up to n. Okay, except we are taking this condition for all the ports except for ith port, that is where you are having the fields EI and which produces the fields EI and HI. Okay, and for the jth port, that is which gives you the fields EJ and HJ. Okay, we are considering this condition Vn is equal to Vn plus Vn minus is equal to 0 for all ports, that is n is equal to 1, 2, 3 up to n, except for ith port and j port, where which produces the fields EI and HI and EJ and HJ. Okay. Now we'll consider according to the Lorentz reciprocity theorem. Lorentz reciprocity theorem. Considering a volume containing two sets of sources, that is I and jth port, each produces the fields EI, HI and EJ and HJ. Here we are considering Lorentz reciprocity theorem. Okay, so that is considering a volume containing two sets of sources, that is I and J port, which each produces the fields EI and HI, okay, EJ and HJ. So from this theorem we can write